Good morning, everyone. In this class, let us try to solve this knapsack problem. What is a knapsack problem? Knapsack is a bag which has some limited capacity, and we will be given some sort of items, and we can take any item which fits the bag. So our target is to take the items such that the value of the bag is the maximum. Okay. The statement will be given like this: given a set of items, each with a weight and a value, determine the items to include in a collection. Which items you want to take, so that what is that I want, the total weight is less and less than or equal to the capacity of the bag, and the total value is as large as possible. This is our target. This is about knapsack. Okay, so assume that 3 items. Okay, so and the weights are like this. Let weight be 10, 20 and 30. Okay, this is very simple problem I am taking, and values being something like this. Okay, so for the value of the first item is 60 rupees, the value of the second item is 100 rupees, the value of the third item is 120 rupees. Okay, so the capacity of the bag, let the capacity of the bag be 50. Now the target is find out which items you will take. Okay, item 1, item 2, item 3. In these 3 items, which items you will select. Okay, generally the first item is very less weight and the value is more. For 10 kg I am getting 60 rupees, for 20 kg I am getting only 100 rupees, for 30 kg I am getting 120 rupees. Okay, so I can take 50 kg with me. Which items will I take? Okay, because this is a very simple small problem, I can easily say that I will select item 2 and item 3. So 20 plus 30, 50 exactly fits in my bag, and I will get 220. That is the value I will get. The value of the bag will be 220. Okay, so if I take any other item, assume that if I am taking item 1 and item 2, what will happen? So item 1 and item 2, 10 plus 20, 30. 20 kgs is free, but I cannot take item 3 because it is 30 kgs. Okay, so the amount I will get is 160. So here I will get 160 rupees, and the bag is free. 20 kgs will be free. If I take item 1 and item 3, then what will happen? So 10 plus 30, 40 kgs is full and 10 kgs is free, but I cannot take item 2 because it is 20 kgs. I cannot break the item and take it. Okay, so the value is 60 plus 120, the output will be 180. So if I take item 2 and item 3, the value of the bag will be 220. Okay, this is known as knapsack problem. The things given is W, V and capital W. Capital W is the capacity of the bag, W is the weight of each item, this is a list, and V is the value of each item given in a list. Okay, so the number of items is N and it is 3 here. Now we want to solve this problem. Okay, let us go to the PPT and see how to solve this. So to solve this problem, we will write a function knapsack, and it will take 4 parameters. One is the capacity of the bag, capital W, list of weights of the items, small w, values of the items, V, and number of items, N. This is how we will write our function. Okay, so to solve this problem, we will go step by step. That is, we will take one item and decide whether to keep it in the bag or leave it. So let us start with the nth item. Its weight is Wn and its value is Vn. There are 2 options: to select the nth item and keep it in the bag, or reject that item. Okay, let us see what happens when we select an item or when we reject an item. In both cases, the problem will be reduced. Whether you select the item or you reject the item, the problem will be reduced. How? We will see this. If the nth item is chosen, if I select the nth item, okay, and put it in the bag, what happens is the capacity of the bag will be reduced to capital W minus Wn. Because I already put one item, the empty space will be reduced and the number of items will be reduced to n minus 1. Earlier the number of items is n, whereas I have taken one item, the leftovers will be n minus 1. Okay, the value of the Knapsack will be, okay, V of n, that is the value of the nth item, plus Knapsack of W minus Wn, new capacity, comma, weights, comma, values, comma, n minus 1, number of items is reduced by 1. Okay, this is what will happen if I choose that item. Assume that if I have not chosen, if the nth item is not chosen, then the capacity of the Knapsack will remain capital W. Capacity is not changed because the bag is still empty. I have not added any item in the bag. Okay, the bag capacity will remain the same, but the number of items will be reduced because I have decided on one item, I kept it aside. So remaining items, I need to take the decision on the remaining items only. So the number of items is reduced by 1, that is n minus 1. The value of the Knapsack will be Knapsack of W, that is capacity of the bag. It is not reduced. Previously I have reduced it. Okay, weights, values, and number of items is reduced by 1. Okay, these are two things we should remember, because when we solve these problems, we should go by step in small steps. Okay, we will decide on each item. When we decide on one item, we have two options. One is whether to take that item or to leave that item. When we take that item, your value will be increased by that item's value and the remaining Knapsack. The problem is reduced to n minus 1 and capacity is reduced to capital W minus Wn. Okay, so based on this, when I decide on one item, the problem was reduced to the similar kind of problem. It is a Knapsack of n minus 1. Previously it is a Knapsack of n. It is something like factorial program, which we solved using recursion. So this Knapsack problem can also be solved using recursion. Okay, this problem can be solved using recursion. Okay, whenever we think of recursion, we should keep in mind of two things. One is what is the base case, when will this recursion will end. The second one is what is the recursive case. Okay, let me see. The base case for this problem is if the bag is full, that is the capacity of the bag capital W becomes 0, I have to stop. Or if the number of items is finished, that is n is equal to 0, I have no other item to choose, then the problem is finished. Okay, when the problem is finished means if capital W is equal to 0 or n is equal to 0, return 0. The problem is finished, I need not change the value of the problem, so return 0. Okay, otherwise the recursive case is if a particular element, let us assume that I am thinking of the nth element. If the weight of the nth element is greater than W, I cannot take that because that cannot be fit into the bag. Okay, if the weight of the nth element is greater than W, then don't choose it. So return Knapsack of capital W, V n minus 1. This is when we don't choose a particular element. Okay, else if that can be chosen, then again I have to decide whether to choose it or not. That is depending on the value it is providing me. My target is to get the maximum value. So else case, I am telling that return max of V of n plus Knapsack of capital W minus Wn, comma, W V n minus 1. This is the case when we choose the particular item, comma. This is the case when we don't choose the item. In two cases, which one is returning the maximum will be selected in the else. Okay, return max of V of n, value of n plus Knapsack of capital W minus Wn, that is new capacity, comma, weights, values n minus 1, or Knapsack of W, weights, values n minus 1. So this case when we don't choose the item, this case when we choose the item, which is the best one will be decided by the max function that will be written. This is how our program can be solved. Let us go to idle and try to solve this. Okay, I am creating a new file. Let me save it on desktop and call it as Knapsack 1. Okay, I am writing this function to To write any function, use the keyword def. And what are the parameters? Capital W, small w, v, n. Exactly what we have seen in the slide. Okay. What is that I need to do? What is the base case if capital W, capacity becomes 0 or no items left, that is n is equal to 0. I should put double equal to. If w is equal to 0 or n is equal to 0, what should I do? I should return 0. Okay, that is in base case. What is the recursive case? If weight of the nth element means n minus 1 because indexing starts with 0. So weight of the nth element is greater than the new capacity, that is the capacity of the bag, that is the empty space in the bag, then I cannot choose it. So simply return knapsack of the case when you don't choose w comma w v and minus 1. Else, if the weight of the nth item is less than the space available in the bag, then return max of. Again, I have to think whether to choose it or not. What happens? When will I get the maximum value if I choose it or if I omit it? So I am checking those two options. Value of n minus 1 plus knapsack of w minus w of n minus 1 comma w v n minus 1. Exactly what we have seen. I have to put the second option when I use max. When if I don't choose what is the value, I have to put knapsack of w, weight won't change, small w, v n minus 1. Okay. Okay, this is our problem. Now let us try with this particular data set. Okay. So if name equal to main, I am taking capital W is equal to 50. W is equal to list of weights. What are the weights I am taking? 10, 20, 30. Value is equal to value of the first item $60. Let us assume. Second item $100, $120. And what is n? N is equal to length of W. Okay. How I initialize n? That is okay. Now I want to call the function and print the value returned. Knapsack capital W, W, V, N. What should be the output? It should be 100 plus 120, 220 should be the output. Let me run the program. Okay. You can see 220 is the output. We can change the values. Let us assume that it is getting more money than this 100 and this weight is 20 only. In this case, what we will do, we will take all the 3 and the output will be 320. What is the program doing? Let me run. 320. So it took all the 3 elements. Okay. We can change the values and check, it will work very fine. This is knapsack problem. Okay, thank you everyone for listening patiently.